Okay, today in Honors Chemistry, we're continuing on with ionic compounds, but today we're going to, it's no longer going to be a binary compound, it's going to be a compound with at least 3 elements in it. And so they're sometimes called ternary compounds. Keep in mind that I gave you a table with some ions on it. You're supposed to make note cards on those and start memorizing them. Polyatomic ions, you have got to memorize them. It just takes a lot of practice, but you can do it. Okay. Polyatomic ions will contain 2 or more elements that act as a unit. So here is just a simplified list of some polyatomic ions. So notice that all of these have charges. So like HSO3 minus, NO2 minus, SO3 2 minus, PO4 3 minus. But these will be the oxygen in phosphate. These 4 oxygens will be covalently bonded to the phosphorus, and then this 3 minus charge applies to the whole ion. Okay. Most are oxyanions, simply meaning they contain oxygen and are negatively charged, hence the word anion. Except for NH4 plus is a positive polyatomic ion. It is ammonium. The charge on the polyatomic ion will apply to the whole group. Most of the polyatomic ions will end in ite or ate. 8 will always have 1 more oxygen than ite, so it's like at 8, it's oxygen. The exceptions are OH minus is hydroxide, CN minus is cyanide, and NH4 plus is the ammonium ion. But it makes it simple because there's not an element called hydroxide, nor is there an element called cyanide, so these have to be polys. Okay, to write the formula, simply treat the polyatomic ion as if it were a single ion by keeping it together as a unit. First, write the symbol and charge for the cation, so your positive thing is always written first, then the anion, then balance your charges using the crossover or crisscross method. Remember, charges between positive and negatives must equal 0. If you have to have more than one of your polyatomic ion, you will put the entire polyatomic ion in parentheses without the charge. Now make sure you keep its subscripts intact. Write a subscript outside the parentheses to show the number of polyatomic ions in the compound. Never change the subscripts within the polyatomic ion. Okay, so for instance, if we're doing sodium and nitrate, so sodium, remember, is Na, its charge is 1 plus. Nitrate, so go to your polyatomic ion chart, make sure you look up nitrate and not nitrite, so it's NO3 minus. So NO3 minus, that's 1 nitrogen, 3 oxygens, make sure that is a capital O. That equals 0, so your formula would be NaNO subscript 3. Okay. For calcium and phosphate, calcium is Ca, its charge is 2 plus. Phosphate is PO4 3 minus. Make sure you're looking up phosphate. They don't equal 0, so we're going to crisscross. So we're going to say you have to have 3 of the Cas and you're going to have 2 of the PO4s. So written correctly, you would write that as Ca3, open parentheses, PO4, close parentheses, 2. Okay? Remember, we do this to balance your charges. This makes this a 6 minus, 6 plus. Sodium and hydroxide. Sodium, once again, is Na. Charge is plus. Hydroxide is OH. Charge is minus 1. They equal 0, so you would write that as NaOH. Okay, so put this on pause for a minute and you try the next couple. Okay, so calcium is Ca2 plus chlorate. Now listen, on the polyatomic ion chart, you have 4, so you have hypochlorite, chlorite, chlorate, perchlorate. So make sure you pay attention to that, okay? So chlorate is ClO3 minus, and that's for chlorine, so it's not an I, it's an L. ClO3 minus is chlorate. They don't equal 0, so you're going to have one of these and you're going to have 2 of your ClO3s. So you're going to say Ca, open parentheses, ClO3, close parentheses, and you'll have 2 of that polyatomic ions. Aluminum is Al3 plus, carbonate. CO3, 2 minus. They don't equal 0, so we're going to crisscross. So we're going to have to say you have 2 ALs and you're going to have 3 of your CO3s. So your formula would be Al2, open parentheses, CO3, close parentheses, 3. Okay, to name them, name your cation first, followed by your anion. Remember, if the cation is a transition metal or metal in the stair steps, with the exception of aluminum, silver, zinc, or cadmium, you need to determine the charge and place it in Roman numeral after the metal's name. Okay, so name the following. So hopefully you realize that copper is transition metal, so we're going to give it a Roman numeral. So we're going to look at SO3. Let's get this over here where we can see what's going on. Okay, so SO3 is sulfite. It has a 2 minus charge. So if this is a 2 minus, then this side is a 2 plus. So you would name this copper, Roman numeral 2 in parentheses, sulfite. Cu2SO3, so SO3 is still a 2 minus. This side has to be a 2 plus, so you have 2 coppers. That means they're each a 1, because 1 times 2 makes that a 2 plus. So you would name this copper, Roman numeral 1 in parentheses, sulfite. Okay. The next one, silver. Silver is a transition metal, but its charge never changes, so we would simply name this silver nitrate. And then SnSO4 2 minus, so tin is a transition metal. So we're going to determine its charge by looking at SO4. SO4 is a 2 minus, but you have 2 of them, so that makes that a 4 minus. So this side has to be a 4 plus, so you would name this last guy 10 Roman numeral 4 in parentheses, sulfate. Okay? All right, so that finishes up that set, and so now you can do set 2B, or I think it may be set 3, ionic compounds involving polyatomic ions.